Here's another example based on the material from chapter 5.1. So the speed of a cat is given by this formula. V of t is 2t squared. So this is a little different than what we did in class. So in class, we knew what the speed was, but that's either because I gave you a table of data or I made a graph and we just read the velocities off the graph. Now we have a function that tells us the speeds. And we want to know how far the cat runs from, say, time 1 to time 4. And let's use a delta t of 1. So we're going to do the same sort of thing. We're going to lie a little bit and pretend it's constant during this delta t of 1. And we'll form a left-hand sum and a right-hand sum. And the difference now is that instead of reading the speed off a graph, we're going to ask a function to tell us the speed. So let's see how this is going to work. As with the graphical examples, a tiny bit tedious, but not too bad. All right, so how far does it go from t equal 1 to t equal 2? So how far from t equal 1 to t equal 2? So I'm going to use vt, distance equals rate times time, and we'll have to think about what we're going to plug in here. So for v, it's changing all the time, but we're going to pretend it's constant, and I'm going to choose the left-hand value for that. It's a little less obviously left because now it's not on a graph, but left it just means in this context the first. I'm going to choose the first value in this time interval from t equals 1 to t equals 2. So I'm going to choose v1, and t will be delta t of just 1 second. So now the left-hand value, I know what that is. I have a formula for it now. Before you read this off a graph or a table. Now you just need to plug into the formula. What's v of 1? Well, we just plug in. v of 1 is 2 times 1 squared times this t, that's also a 1. And 1 squared times 1, that's 1, so this whole thing is 2. So that's how far it goes. And I should mention, let's see, this is a left-hand sum. That's how far it goes from t equals 1 to t equals 2. Let's do t equals 2 to t equals 3. So t equals 2, t equals 3. So again, distance is rate times time. This formula only applies if v is constant, which it isn't, but we're just going to pretend that it is. And again, we're going to choose the first or the left value in this interval. So the interval is from t equals 2 to t equals 3. So the left value is 2. So I'm going to say v of 2 times 1, since delta t is 1. What's v of 2 before we read it off a table or a graph? Now we just ask the function. We plug it into the formula, plugging in 2. This is 2 times 2 squared times 1, and that looks to me like 8. 2 times 2 times 2 is 8. All right, just one more step to go. T equals 3 to t equals 4. Again, we'll use vt, distance equals rate times time. What rate do we choose? It's changing all the time. How do we pick one? We're just going to choose the one on the left. So that's v of 3. Times t, that's our interval, that's just 1. What's v of 3 before we read it off a table or a graph? Now we just ask the formula. So that's 2 times 3 squared times 1. That's 18. So the total left-hand sum is this plus this plus this. Let's see, 18 plus 2 is 20, 20 plus 8 is 28. So that's what we have for our left-hand sum. So we did the left-hand sum. For completeness' sake, let's do the right-hand sum as well. So we'll do the right-hand sum. And we'll break it into 3 steps. because delta t is 1, and 1 to 2, 2 to 3, 3 to 4. So now we want to know how far does it go from t equals 1 to 2. So Vt, distance equals rate times time. This formula is only true if the speed is constant, which it isn't, but we'll pretend it's constant over this time interval from 1 to 2. Which time do we choose? Which velocity do we choose for that bogusly constant velocity? Well, now, since it's a right-hand sum, we're going to choose the value on the right-hand side. That's 2, the end value. So I would say that's v of 2. Delta t is still 1. V of 2 is 2 times 2 squared times 1 is 8. Hey, that's familiar. That's the same 8 that we did here. So just like when you do it graphically, you should be having this sense of deja vu because it's the same rectangle. How far does it go from t equal 2 to 3? Well, again, we'll use rate times time. This is only true if the rate is constant, which it's not, but we'll pretend it is over this interval. And what pretend constant will we use? We'll use the right value on this interval, the endpoint, and that's v of 3 equals 1, and I better answer the phone, excuse me. Sorry about that. All right, let's finally finish this up. So we're using the right-hand value times 3, v of 3 times delta t of 1. V of 3, what is that? Before we looked it up in a table. Now we ask the function. The function tells us it's 2, 3 squared times 1, and that's 18. Again, a powerful sense of deja vu. That's the exact same thing we did before. And now the last one from t equals 3 to 4. Distance equals rate times time. What rate do we use? We use the right-hand rate. The interval is from 3 to 4. The right-hand value is 4. That's v of 4 times a delta t of 1. Oh, we're going to have something new here. What's v of 4? We don't read it off the graph. We just ask the function. 2 times 4 squared times 1. 4 squared is 16. 16 times 2 is 32. And let's see, 32 plus 18 plus 8, I think is going to be 58. But I'm not feeling confident, so I'm going to use a calculator. Even though I probably shouldn't. 58, yep, should have been confident. So that means that the total distance traveled, according to this right-hand sum, is 58. So our left-hand sum was 28. Our right-hand sum was 58. That's a pretty big difference, but that's because we had a big delta t. If we needed to figure out more precisely how far the cat went, we could let delta t get smaller and smaller and smaller. Okay, so the main thing that's different, the only thing that's different about this example is how we're getting the speeds. The idea behind a left-hand sum and a right-hand sum is exactly the same. We're pretending that velocity is constant over an interval even though it's not. And a left-hand sum takes the left-hand value, the right-hand sum takes the right-hand value, and then you just sum them all up. That's the sum part of sum. And the only thing that's different here is that now we're using it from a formula.